In this video, I'm going to create this striped sock thing with geometry nodes in Blender. I'll be dealing with multiple concepts including shortest edge paths, curves, signed angles, named attributes, and the challenge of attaching a nose on a curve-to-mesh mesh. I use the rig I'm about to create in my alien test scene. This video is part 3 of a series exploring techniques used in that scene. But don't worry, you don't need to have seen the others. This isn't a cinematic universe. It's not even a cinematic shed. First, I'm adding a plane, which is what I'm going to make our creature out of. 40 meters on the X and 8 on the Y. Then, in edit mode, Ctrl R for the loop cut tool, adding enough loops to match the grid on both axes. Applying the scale, then selecting the cube because this is what we are going to attach our geometry nodes to, which we are going to do in the Geometry Nodes editor. I'm disconnecting the geometry input, then adding the plane with an object info node and plugging that into the group output. I want to create an empty group, so I'm adding a reroute which I can then create a group around. This group is where we'll make our path, and we'll be doing that with a separate geometry node, separating edges with a selection from 2 edge path nodes, shortest edge paths and edge paths to selection. These 2 nodes, when holding hands, allow us to select the shortest path between 2 vertices on a mesh. For the start vertex, I'm going to select the one with an index of 0, which is conveniently down here on the bottom left-hand corner. For the end vertex, I'm going to switch to edit mode and create a vertex group called target. Then I'm going to select this very lucky little point over here and assign it to the group before plugging target into the end vertex with a named attribute. And now we have the shortest path between the 2 indexes. This shortest path may be right, but that doesn't mean it's interesting, which is something my ex-wife used to say a lot. To make a more scenic route, we can use the edge cost input. By default, there are no tolls on the roads of shortest edge paths, but we can assign them, assigning a cost for each edge. When the shortest edge path is calculated, it's actually searching for the shortest and the cheapest, which happens to be a half-accurate description of Tom Cruise. You can plug any float value into cost, using cost inequality to shape the shortest path in countless ways. I crave chaos, so I'm using a 4D noise texture to create a random path controlled with the W, hooking it up to the group input, then adding some subdivision at the start to give the path more edges to choose from, converting the path mesh to a curve and subdividing the separated path itself, but not too much. We don't want to burn the house down. Right now, our path looks like Pac-Man's escape plan, so to turn it into something more organic, I'm going to blur the point's positions with the blur attribute node. This mixes the position vector of each point with its neighbors, each iteration mixing the positions created by the one before it. This works well in 2 dimensions, but some of you are big fans of the third, where the blur attribute has destroyed the path's corners. To stop this, I'm going to use the edge angle node, storing the signed angle as a named attribute at the beginning of the group. The signed angle is the angle between 2 faces. It allows us to mathematically identify our corners. The higher the value, the sharper the bend. Plug the signed angle attribute into the blur's weight via a map range node. Then you can tweak it so that the blur only happens below a certain angle. Next, I'm setting the spline type to Bezier and the handle type to Auto, then exiting to the main group and renaming where we've been the path group, hooking up our cost W to the group input and adding another reroute to make another group. This is our geo group. Converting the curve to mesh with a curve circle profile, adding a set shade smooth node because I just can't help myself, then naming this group Geo before making space between Path and Geo and adding another group. I've ditched the geometry and plugged a curve line into the output instead. A curve line resampled by the number of points on our input curve. And now I'm setting the position of the points on the new curve by sampling the original curve. If I multiply the sampling factor, I can expand and contract the new curve along the original. This is how we'll control this thing, so I'm connecting it to the input as factor. Next up, let's tackle the radius. We can drive this with the factor, and though this shape might be useful if Helm's Deep is in trouble, I'm going to use a flow curve to give it a fluid shape that tapers towards the front. Because there may well be times when this thing needs to puff itself up to assert dominance, I'm adding a control to multiply the radius. I am now going to address the fact that my geometry seems to be half embedded in the ground plane. But first, I'm renaming this group Rig and plugging the factor and swirl controls into our group input, then diving back into the path group. Here, I'm going to store the mesh's normals as a named attribute. This named attribute will survive the conversion to a curve, making the normal vectors available to us on the other side. I'm calling it surf norm. Back in Rig, remembering that the new curve is mysterious and has no past, I'm going to store surf norm on it by sampling the original curve. Now it's up to date, we can use the surf norm attribute to offset it, thus offsetting it in the normal direction of the surface that it is on. If we scale this by the curve's radius, the geometry now sits flush with the surface. I can create a float curve that only affects the radius of the last 1.8 meters of the curve by mapping the length parameter from a minimum of the curve's full length minus 1.8 to a maximum of the curve's full length, adding the float curve and then multiplying the result into the radius. I shaped the float curve to give the striped sock creature their distinctive personality. Now it's time to store the factor of the new curve onto itself as an attribute called fixed factor. This one is fun. If you redefine fun as something that isn't fun. Now I can clamp the factor by its fixed self, and if I distort the fixed factor with a float curve, this clamping can shape the distribution of points along the curve. Here I have bunched them towards the start and the end. And these redistributed points can have some interesting consequences. Here on the move out, you can see that the back of the mesh stops moving before the front, and on the move in, the reverse. This is especially satisfying when it's textured, but you don't have to take my word for it. Guess where we're going next? Out of the Rig group and into the Geo group for our final geometry node push. I'm simplifying the geometry before adding a subdivision surface node because I was taught to always be cautious when handling dangerous tools. An unmotivated cut to our material nodes to keep everyone awake. Wave texture bands on the Y given color with a color ramp. Adding this with a set material node, but it won't work yet because we need to set the UVs. I'm going to do this in the same way that I did on my twisty stick video. But if you happen to be one of the very few people in the world who didn't watch that video, here I am doing it all again. Using trim curve to unroll the curve circle, capturing its factor, combining it with the fixed factor to make our UV coordinates, merging by distance to undo the trim, then remembering to tell the material to use this UV map. And now we have our rings. But as Roxanne once famously said, what are we going to do about the nose? Well, for this, I'm going to model a mesh, starting with a circle with the same number of points as our curve profile, 8. Extrude, scale, fill. Some knife tool quads and triangles, then, to get the dome shape, some light rearranging. Having made the mesh, I'm now going to assign the vertexes at the bottom to a vertex group called tip. This may not make that much sense now, but trust me when I tell you that it still won't make that much sense later. Okay, enough of that. Back in the geo group, I'm adding another named attribute to the curve, a boolean called tip. Using endpoint selection, only the last point in the curve is true. Then instance on points, which I'm joining back in after our UV nodes. Using the tip attribute with the instance on point selection so we can instance the nose on just the tip. Then for the rotation, the classic double align Euler to vector with normal and tangent. And radius for the scale. Realize instances to turn our nose instance into a mesh and merge by distance to connect it to the body, with tip, which is both a vertex group and an attribute, as the selection. And the very last thing to do is fix the nose UVs. I'm going to use the project from view UV option, whilst looking at the nose from the side. This aligns the stripes, but the scale is wrong. So I'm scaling down the mesh in the UV editor. Before I go, I want to mention that if you have an intricate path mesh with lots of turns and corners, it's best handled by creating a simplified proxy mesh like this. Anyway, that's it for today. Remember to tweak your signed angle mapped ranges. We're all different, you know. All of us. Singular. In our own special way.